I think we're live. Hey, everybody. Thanks for joining us today. I'm Dave Ward from Packet Fabric, and with me is Anna Claiborne, our SVP of Product and Engineering. And we'd like to chat with you about how the internet architecture has changed, where network is code and WAN is really the cloud. And so we're from Packet Fabric, which is an API-driven underlay. And we'd like to tell you a bit about this and really what this means to, again, a changing internet architecture, as well as what it may mean to you and your business. So really the thing that we've focused on at Packet Fabric is creating the notion of a cloud core. And the agility of that cloud core is really that we are API driven. Of course, we have a user interface, and we'll talk you through that. But what we're trying to do is create a real-time, on-demand network between all of the data center operators, public cloud, SaaS offers, security clouds, storage clouds, unified collaboration clouds, et cetera. Really what's necessary to run an enterprise IT stack for productivity as a service. And it really throws the legacy architectures of static networks, long provisioning times, long terms on its head. And so to that point, look, the options you get today are really, let's say, MPLS, VPNs or VPLS, and there's some benefits of those technical architectures, which we've spent a long time working on, but that agility to be able to get to the cloud services you need is extremely challenging in an MPLS environment. If you're building only DIA, hey, look, you can get the bandwidth you need, but how do you get to the multiple clouds? And then if you use the internet, you can get anywhere you want to go, but you don't have security, privacy, and you don't have bandwidth engineering, and you don't have latency engineering. And so there's these trade-offs with all these legacy architectures. Well, step forward one, here comes Packet Fabric. And really what we've focused on is that real-time, on-demand, integratable APIs, such that all of the provisioning, the negotiations, the deployment time really doesn't exist in our network because we're already deployed to those clouds. And so that notion of real-time on-demand is that you can go into using our APIs or our portal, sign up instantaneously, actually provision the connectivity you want and need in under a minute. We'll automatically test it and you're up and running. So the entire service to get to a cloud or multiple clouds or build your own network or build the connectivity you need is all the way down to a minute, single minutes. And that's what real-time on-demand internet is all about. And we've focused really primarily on that cloud core piece. So as the WAN or as middle mile becomes cloud, look, it means network is code. It means it's on demand, as you can read here. You can consume and increase your bandwidth or decrease your bandwidth on demand. And really this allows you to run your network and run your business where you need it to go with the bandwidth and engineering that you need, where we're owning and managing and operating all of the kit underneath. And you can focus on your business and you can focus on what you need to deliver from a service point of view across these multi-cloud workflows or in a hybrid cloud environment. We are the only network that has built a high-speed 100 gig, multi-100 gig, 400 gig connectivity to these clouds. We, of course, have lower speeds, fully redundant, spectrum redundant, hardware redundant, and we're delivering network as a service. What we really build is the automation and orchestration platform to deliver network as a service. So these are the products that we offer. Traditional, classified traditionally of point-to-point, hybrid cloud, multi-cloud, and then build your own network. And as you can see, what you're able to do with these pieces from a traditional product point of view, really what you're able to now do is instantly build your own cloud network and cloud connectivity, manipulate the bandwidth through APIs, which can be driven directly from application workflows or from storage archive or from your security needs. And what we provide that's fundamentally different than legacy architectures is we remove the traffic tromboning. We actually can have built our fabric such that you can move data intercloud between the multiple private clouds and private data center offers, et cetera, using our network and our cloud router. And Anna's going to talk to you a bit about this into the future. We are fundamentally different than an SD-WAN. An SD-WAN, of course, is an access tunnel that goes to a gateway somewhere and provides an overlay service, which has uncontrolled bandwidth and uncontrolled latency and uses the internet for access and internet for core services. We are a private, secure network. And so also what I wanted to say about the SD-WAN architecture is, although there's a movement from Gen 1 SD-WAN to Gen 2, which is a SASE model, SASE, a secure access and secure edge, what that architecture actually creates is that your traffic is tunneled to a SD-WAN gateway, then potentially may go to a security cloud, then maybe potentially go to a storage cloud, and then may go to a SaaS cloud. All of this requiring hairpinning and uncontrolled use of the internet and the connectivity that has no control on underneath it for the bandwidth latency that you're going to get. A private network and a private secure fabric between these clouds fundamentally can drive the experience, fundamentally can drive the bandwidth and latency that your applications and users need. So we are not an overlay network. We are the underlay network that is really a next-gen service provider with a network as a service platform on top. Now, what I'm going to do is I'm going to turn it over to Anna now, as she's got the architecture up, and she's going to walk you through a little bit deeper into the technology of how it's built, and then really how it can be used. And she's going to show you some examples.
Thank you, Dave. So we're going to take a little bit more of a deep dive here into what exactly a new carrier network looks like and how this is greatly differentiated from SD-WAN. So we start at the very bottom layer, which is the optical network. This is not the case of cloud where it's just someone else's computer, AKA we're someone else's network. This is our network. We run the DWM gear. We lease the dark fiber. We do the hard stuff so everyone else doesn't have to. And on top of that dark fiber network, we have our own Ethernet fabric that provides the layer 2 and layer 3 services that you saw on the previous slide about use cases. So that provides all of the hybrid cloud connectivity, multi-cloud connectivity, and co-location connectivity that spans a wide variety of use cases. And the great thing about operating our own network from the ground up is that we can provide an exceptionally resilient network. In fact, we have a 5 nines core SLA. And this is because we are running, 2 to n different fiber paths out of every single location that we're in, as well as multiple connections across multiple continents to all the different cloud providers. And we also have over 50 terabytes of network capacity now. So there is plenty of room on the network for everyone. So on that foundation of our own optical and Ethernet network, this is what we've built: an API and a portal on top of. And what this enables, since we own the entire stack, this is not SD-WAN running on internet, is it gives us this complete flexibility to create a portal and an API to access any service, and as well as create super flexible pricing options to sit on top of that. And because it's our network, we want it to feel like your network, and we provide real-time visibility and telemetry into all of our services. And to dive a little bit more into what the stack provides is so cloud connectivity. That's both in the form of hybrid and multi-cloud. That means that you can connect any co-location facility. So for example, if you're running a database in co-location and your web front end in AWS, we can provide direct, secure, and fast access between that database and that web front end to make sure that your application is really responsive for your end users. It also means multi-cloud connectivity, so that you can run different scenarios across different cloud providers and utilize whatever cloud provider best suits your use case. This can work for a variety of things: AI, biotech, for example. If you have a vast storage of genetic information in one cloud and want to do the processing in another, it's not a problem. We offer 100 gig connectivity between the different cloud providers. And also this since we are in almost 200 co-location facilities across the United States, Europe, and Australia. This means that you can also interconnect any data centers that we are in just minutes. And as well as the basic services, you can interconnect to anyone else on our platform. And so this takes care of things like private peering or connecting to internet exchanges, so that you can exchange business with, or you can exchange traffic with the businesses that matter most.
Hey, Anna, as you're about to get into this slide, how is this platform different than a traditional SDN network, and using an SDN controller, or maybe just, some kind of vendor tool that claims automation and orchestration? What have you done different with your net dev team?
Sure. So any orchestration, any SDN orchestration platform is going to claim, you are still ultimately the one running the network. You're responsible for the infrastructure, and any SDN tool is just providing some level of orchestration on top of that. And so you're still stuck with a lot of capital expense to get all that infrastructure up and running, and also the operational care and feeding of that. Whereas what we have built is we have built an actual carrier network. So we are responsible for the infrastructure, the care and feeding of that infrastructure. And it's part of what our deep expertise is that, that's what we do, is run networks and make sure that they're truly resilient. And under the covers here, as far as managing our own network, it is very, very automated. We have really slick things like completely automated upgrades to all of our infrastructure that happen without a person having to be there. And, so the way I look at it is, our job is to take care of the network so you don't have to. Because no matter how much orchestration in the terms of SDN or SD-WAN you layer on top of the internet, you're either still stuck with taking care of a private network yourself, or depending on the internet to be safe and risk-free, which we all know that it's not.
What I found interesting, Anna, is that when you built this and your team built this, you didn't start with some vendor's SDN controller, and you didn't start with what's available in the market, simply because they were either not redundant, not the code you wanted to use, and really not providing the services, which was natively cloud first, and natively cloud, the ability to scale out and perform using resources that are necessary to run that entire network. Maybe you could spend a second just talking about what's different between your software architecture and others that are out there.
Sure. We built everything, our entire stack. So what powers the incredibly wonderful portal and API that we have that allows you to interact with the network real time is a software stack that we built from the ground up, because exactly as Dave said, there's just nothing out there that performed the way we wanted it to perform, and provided the options that we wanted it to provide, in terms of allowing us complete flexibility to connect anything to anyone at any time. And so that's a huge differentiator in terms of that we are not subject to the whims of someone else's software. We can very quickly respond to customer requests. That's we have this fantastic NPS score, which is a customer satisfaction score that is so far beyond anyone else in the telecom industry that it's not even funny, because if a customer comes to us and says that they would like a feature implemented, we can usually get that turned around in a matter of weeks, whereas you can't even get a telecom circuit provisioned in weeks. So with this,
I think also what's interesting, Anna, is that whether or not you have religion, certainly when it comes to technology, you're multi-denominational, because you also didn't get stuck following the whims of this SDN protocol or that one. Because you're a net developer team, you actually could use whatever is presented to you to solve this problem. So you weren't stuck behind, does this OS have all the APIs necessary, or does this optical widget have the APIs or protocol support? All of those debates of the past of SDN, I think, frankly, you managed to overcome. Maybe you could spend a second talking about the multi-denominational nature of what you've built.
Sure. We like to think of ourselves as hardware agnostic. So we can use any underlying hardware. To us, network is network. It's made of the core protocols that all the RFCs are written on, and um, we can interact with any of it. So doesn't really, ultimately what that means is that, we feel like a SaaS application to the end user, or like a cloud compute platform, because the end user doesn't have to have any awareness of what's actually running under the hood. It doesn't matter if it's Cisco or Juniper or Arista, or Nokia. It's all gonna be the same. And through our API, and it's just through our API, same as you would access any cloud resources, that you're going to be controlling the network. And so this allows you to do fun things like integrate to your CRM systems, integrate to your NMS or monitoring systems, do service desk type workflows, and of course use all the DevOps tools that you've come to know and love from working with cloud providers like Terraform or Ansible. And we have all the SaaS things that you would expect to see, like a nice online knowledge base, REST APIs, GitHub examples, all that incredibly fun stuff. So we're going to move into the demo here before we run out of time. And so the use case we're going to cover is data storage in AWS and compute in Azure. And in the demo, we just have random data being generated via a Kafka pipeline. And if you want to compare this to a real world scenario, it would be like if you were doing, say, something in 3D rendering, it would be like storing your source files in AWS S3 and then actually doing your rendering on Azure. And this demo is going to show that latency, not just bandwidth, is critical for the throughput. And of course, that this whole solution is powered by network as code. This is set up with Python code. And the wonderful conclusion of this is that Packet Fabric has about more than double the throughput versus VPN over internet. So not only can you tear up and tear down your network solution just like your cloud solution, but it also performs much better. And down there is the docs for doing this. So here's an overview. Well, actually, I hit play on the video. Here's an overview of the solution. So let's say that you're doing this rendering, right? And on your laptop, you have a rendering time, like one frame takes 10 minutes. And you're going to create a 5-minute short movie at 25 frames per second. That would take like about 52 days. And if you want to do that faster, you'd stick it in the cloud. So you're going to stick your source files in AWS, and you're going to do your rendering on Azure. And so right now, so this shows the Packet Fabric Cloud Router is connected to AW and Azure by a 1 gig connection. We support up to 100 gigs, but the VPN, the site-to-site VPNs are limited to about 1.25 gigs. So we got to compare like to like. For testing purposes, we're using AWS managed streaming Kafka, and we're using Azure VMs in a Kafka pipeline. And the metric that we're going to be measuring here is actually going to be batches a second that we're transferring with Kafka. Obviously, a higher number of batches is better. For this, there was a great AWS tutorial that I used getting started using Amazon MSK. So what we're going to have is on Azure, we're going to have the render farm, and these are 2 VMs in the same VNet. And then in AWS, we're going to be generating traffic with iPerf3. And so, one VM in Azure is going to be running the Kafka pipeline, and then 1 VM in Azure is going to be running background noise. So the Kafka producers are going to send approximately 150 megs, and the background iPerf noise generation is going to be about 800 megs. So we're going to have a total of 950 megs running through this for our test. Then the reason why I use 950 megs is because it's well below the 1 gig limitation of the Packet Fabric service, and also below the 1.25 capacity limitation for the site-to-site VPN. So we're going to be truly testing not total bandwidth, but latency, and then the effect that that has on throughput. And you can see from the past graph there that we were actually pushing 950 megs of traffic. And then that was a brief of showing the data from the Kafka producers. and that we're measuring batches per second transferred between the two networks. And what the result is that over the internet, we see a latency of 133 milliseconds. Well, over packet fabric, we see a latency of 63 milliseconds. And this results in a 225% increase in throughput from AWS to Azure on packet fabric versus the cloud. And when you're talking about a use case like video rendering, and you're taking the rendering time down from something, on a laptop from minutes down to milliseconds, what happens is that your data transfer between sources becomes the bottleneck, and the ultimate throughput and latency truly do matter. And here's a real quick peek at the code. It's not very it's very hard to shove a lot of code on a screen, but this just shows you a quick example in Python of the login and then the actual Cloud Router AWS connectivity. And in summary, an API-driven underlay enables you to actually create this agile cloud core, which is the connectivity that's needed today, because the center of information has shifted from static locations like the enterprise IT campus, co-location, private data center, and it's now distributed throughout these locations and cloud and SaaS providers. So you have to be able to connect all of those things very quickly. So if your network needs privacy, security, agility, throughput, and programmability, which all of them should have, legacy telecom solutions and the internet just don't meet these requirements anymore. The network has to behave like code, just like cloud compute does, to launch the agility that we need anymore. Thank you very much, everyone.
Hey, thanks, Anna, for that. And really, the network as code is really what we wanted to drive home here. And in particular, that when the network is code, it actually adds extreme value to creating these multi-cloud workflows and that cloud connectivity. So again, thanks, Anna, for jumping into that deep dive in that demo and showing the true value of a secure private network. And thanks all for listening.
Yeah.
Have a great day.
Thanks, everyone.